So we'll be seeing a problem. The problem says design DFA to check whether given string does not contain 100. So this problem is does not contain. Previous one we had seen was containing 100, where the input is 0 comma 1. So this is the input that is given 0 comma 1. So again we'll be starting with the logic part, and then we'll go to the implementation. So this is similar to the previous problem. So the logic remains the same. So we will have here summation input is 0 comma 1. States will also remain the same because we are having a substring 100. So we'll have q0 representing 0, q1 representing 1, q2 representing 10, q3 representing 100. Q into summation gives q. The table will also remain the same. Now what happens is we'll draw the table again and check what is the difference between contains and does not contain problem. So we'll start with the table. The logic remains the same. The implementation part will make the table again. And then we'll make the transition diagram and check with the input. So Q and summation input is 0 and 1. We are starting with Q0 state. This is the start state, which represents 0. Q1 represents 1. Q2 represents 10, as we have to deal with substring 100. And 100 is represented by Q3. Here we are not finalizing the states. The question is does not contain. So the table that we have made for contains, it will be similar to it. So 0, 0 as the input. So we are getting 0, 0. Is there any state for 0, 0? No. We will ignore left 0. So we go to Q0. 0, 1. Is there any state for 0, 1? No. Single 1. Yes, there is a state called as Q1. So we write Q1. In state Q1, input is already 1. Then a 0 comes in, so we get 1, 0. Is there any state for 1, 0? Yes, there is a state for 1, 0, which is Q2. Then 1, 1, 1 is already present. Another 1 comes in. Q1, is there any state? No. So we ignore the left Q1 and we search for a state with single Q, a single 1, that is Q1. 1, 0, 0. Yes, there is a state representing 1, 0, 0, which is Q3. Then we have a state representing, is there any state for 101? No. For 01, there is no state. For 1, yes, there is a state for 1, which is Q1. Now the question says, does not contain 100. Means what? If it contains 100, we have to reject it. So previous case, Q3 was the final state. Here the transition will also be the same. So once you go into Q3, you will stay in the same state Q3, even if the input is 0 or 1. Just what we will change is the final state will change. In the previous case, if you see, Q3 was the final state because we had to accept a string containing 100. In this case, we have to reject the string containing 100. So Q3 will be a non-final state and Q0, Q1, Q2 will be the final states. That is the change here. Transition diagram remains the same. Q0 is the final state, Q1 is also the final state, and Q2 is also the final state. Q3 will be a non-final state. This is called as a dead state. Why it is called as a dead state? It is similar to the trap state. Once you get into it, we cannot get out of it. So this is similar to the trap state. This is called as the dead state. So in this case, the logical part, there will be a change in the final state. So if we write F is equal to Q0, Q1, and Q2. So in this case, there is more than one final state. Previous two problems we have seen, there was only one final state. Here, there is more than one final state. And based on this, we'll draw the transition diagram and we'll check it with an example. So transition diagram will have four states, sorry. Q0, which is the start state. Then we have Q1. Then we have Q2. And then we have Q3. So Q0, Q1, Q2 are encircled two times. Q3 is only one circle. So Q0 on getting 0 as the input, we stay in the same state. On getting 1 as the input, we move to Q1. Q1 on getting 0 as the input, we move to Q2. Q1 on getting 1 as the input, we stay in the same state. Q2 on getting 0, we go to Q3. Q2 on getting 1, we go to Q1. Q3 on getting 0 or 1, we stay in the same state. So this is the transition diagram. So these all changes will be there. And we take an example through which it will be a little bit more clear. So in this case, we'll start with 0, 1, 0, 0. We are in state Q0. On getting 0 as the input, we move to the state. We stay in the same state Q0. Then we are having 1, 0, 0. Then on getting 1 as the input, we move to Q1. Now we are left with input 0, 0. Q1 on getting 0, we move to Q2. And Q2 on getting 0, we move to Q3. So which is a non-final state, means the string will be rejected. Means it will not accept a string that will contain 1, 0, 0. Because the problem says check whether the given string does not contain 1, 0, 0. So it should not contain 1, 0, 0. Then only it should accept it. So there are few points to remember in this case. There is always a start state. So in DFA, there will always be a start state. We can have more than one final state. So in this case, we are having three final states. State can also be a final state. So start state can also be a final state. In this case, Q0 is a final state. In such a case, blank input is also valid. So blank input will be valid in this particular case. Dead state is always a rejecting state. So dead state is a rejecting state. So this we require in certain problems like does not contain, and few more problems we'll be seeing. So dead state is a rejecting state. So there is no final state here. Final is accepting state and non-final is rejecting. So Q3 is a rejecting state and other are final states which are accepting states. That's why it is encircled twice. In the previous problem, we had learned about trap state. So trap state is a accepting state. That's why it is a final state, while dead state is a rejecting state. That we need to remember.